Okay, graphing exponential functions. Our objective, graph exponential functions and note their basic characteristics. So we know something from a previous video, an exponential function is any function of the form f of x equals b to the x, where b, our base, is a positive number but not equal to 1, and x, our exponent, is any real number. And as I spoke to in a previous video, in an exponential function, the exponent contains the variable. Okay, so you have a variable or a variable expression in the exponent. So let's graph these, and we'll use a table of values, and then we'll check it with our graphing calculator so that we can see the basic characteristics of exponential functions. Example 1, we're going to use a table of values to graph the exponential function f of x equals 2 to the x. So again, 2 is our base. Again, the base, let me come out a little bit here, go up a little bit. The base must be positive, it's positive. And we just have an x in our exponent to make it an exponential function. So I'm going to use x's around 0, so -2, -1, 0, 1, 2, and 3. And let's do that. So we know it's 2 to the x, so this is going to be 2 to the -2. If you need to put it into a calculator, you can, but the answer is 1/4. Let's put -1 into the function, 2 to the -1, and that's a half. 2 to the 0, well, anything to the 0 power is 1. Okay, 2 to the first, well, anything to the first power gives you back what you started with, so that's 2. 2 squared is 4, and 2 cubed is 8. Okay, so we have an x value and a y value. In fact, we have 1, 2, 3, 4, 5, 6 points. Let's graph. Nothing fancy. I notice that my y values are all positive, while my x values are both positive and negative. So I'm going to focus on quadrants 1 and 2 and have my coordinate graph look like that. And I need let's say I need a -1 and a -2 on the x, and I need a 0, and then a 1, a 2, and a 3. And I need to go from 1/4 to 8. So I'll go like this. I'll go 2, 4, 6. I'll label my y-axis by 2's. So when x is -2, y is 1/4, and that's going to be down here. When x is -1, y is 1/2, a slight bit higher. When x is 0, we get to 1, right in the middle there. When x is 1, we get to 2. When x is 2, now we start to jump, we go to 4. And when x is 3, we're going to go to 8. And we can connect all these points, and I'll use a dotted line so that looks different since I've got a pencil here. I'll just use a dotted line so it's a little bit clearer. And there we go. I'll put arrows on both sides. And this is a graph of the exponential function f of x equals 2 to the x power. Exponential functions, when you have a base greater than 1, start off small, and then they grow, and they start to grow faster and faster and faster and faster. Let's see this in our graphing calculator. So I'll go into here, my y equals, I have something in there, so I'm going to clear that out. And I said 2 to the x power, so 2 raised to the x. And I think my window is, nope, my window is off. So I'm going to go to zoom standard, because my window was changed for the previous problem I did. There's my zoom, there it comes in, and there it takes off. So it's coming in above the x-axis, and then it passes through hits the y-axis at 1, and it starts to take off just like I see it. Couple things to notice. It crosses the y-axis at the point 0, 1. And obviously it's never negative. Your y values are always positive. Okay, so what happens, you're always above the x-axis. Okay, let's do a second one. And this time we're going to have our base be a number between 0 and 1. So give me a moment here. Okay, in this case, I'm going to have the base be a half. Okay, so it's still a positive number, but now it's a proper fraction. It's the number between 0 and 1. Okay, so now let's do the same thing. Table of values, I'll go from -2 down to 0 and back up to 3. And then I want to put my x values into here. So what is 1/2 to the -2? Pull out your calculator if you need to. The answer is 4. What is 1/2 to the -1? Again, if you need to use a calculator, I know this because I had to get myself prepared for this lesson. The answer is 2. What is 1/2 to the 0? Well, anything to the 0 power is 1. We know that. What is 1/2 to the 1? Well, anything to the first power is just itself, so that's a half. 1/2 squared is fairly simple. 1 times 1, 2 times 2, a quarter. And 1/2 to the third, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. So I have the 6 points, -2, +4, -1, +2, and so on. Let's graph it. Let's recognize my x values are negative and positive. My y values are again all positive. So I'll focus my graph again on quadrants 1 and 2 of the coordinate graph. I don't need to worry about below below the x-axis. Okay, so -1, -2, and then I went to 1, 2, and 3. And this time my y values go from 1/8 to 4. So I'll do 1, 2, 3, 4. And I'll graph my points like that, this way. So at -2, I have a +4. At -1, a +2. At 0, a +1. At 1, a +1/2. At 2, a +1/4. And at 3, a +1/8. So here comes the graph, and again, I'll use a dashed line just so it looks a bit clearer to people. It's, of course, a straight line or a solid line, but just for clarity's sake. And this is the graph of f of x equals 1/2 to the x power right there. Okay, we can do it in a graphing calculator, double check what we've done here. Okay, so y equals, I'll clear this one out. I'll put in 1/2. I'm going to use parentheses and then a fraction bar. Fraction bars help keep my fractions straight. So there's 1/2 raised to the, use the caret down here. And I think we were to the x power, make an exponential function, and I'll graph that. And it should look similar. Here it comes down, and yep, same idea. It's coming down from the left side, and then going along the x-axis just like I have here. Okay, notice a couple things again. It again has a y-intercept of +1, and again, all y values are positive. They're all above the x-axis. So we can kind of write these characteristics down so we kind of have a sense of how exponential function graphs look like. So the general characteristics, let me come down a little bit so we can see this graph at the same time. So general characteristics of exponential functions. The domain is all real numbers. The domain goes from -infinity to +infinity. We can put in any x value we want. The range, however, the y values are limited to the positives. They're greater than 0 up to infinity. Okay, and 0 is not included. As we mentioned, the graphs all pass through the point 0, 1. The y-intercept is therefore 1. There's no x-intercept. This graph does not touch the x-axis. Okay, if our base is greater than 1, we went up from left to right. And we saw that previously. We saw that here with a base of 2, the graph goes up from left to right. If our base is between 0 and 1, otherwise a proper fraction, as we see here, the graph goes down from left to right. Okay, it's a decreasing function. And finally, you may have heard this term before. The x-axis in an exponential function is called a horizontal asymptote. An asymptote is a line that guides the graph. Horizontal, of course, means it's a horizontal line. So the x-axis is a line that, as we see here, in this case, as the graph gets closer to the x-axis, it's guiding the graph, in which case it's kind of keeping the graph away as it gets closer and closer and closer. So there you have it, a look at the graphs of exponential functions.